And take the question number 101. Question number 101. I'm reading the question. The equivalent capacitance between A and B as shown in the circuit will be. As shown in the circuit will be. So now here one circuit is mentioned like this. Okay. So this is one circuit given in the problem. This is A and this is B. This is B. Now 4 microfarad and this is 4 microfarad. This is 2 microfarad, 2 microfarad and 2 microfarad. Okay, this is the problem. In this problem, it is very clear that A is positive terminal and B is connected to negative terminal. A and B. A is positive and B is negative. Observe carefully. At this point, the charges are separating. So now here, observe carefully. In this way, this is one path. This is one path. This triangular part is one path. There is no deviation. So this 4 microfarad and 4 microfarad both are in series combination. Observe carefully. This 4 microfarad and this 4 microfarad both are in series combination. Why? Because the charges are flowing in only one direction. There is no deviation. If the charge flow is in one path, no deviation in the charge flow, then we used to say that those two capacitors are in series combination. Thereby here 4 and 4, these two are in series combination, and what is the effective resistance, effective capacitance? The effective capacitance in the case of series combination is Cs is equal to C1 C2 by C1 plus C2. For identical capacitors, Cs is equal to, we used to take it as C by N. C by N. Then Cs is equal to C by N. C is nothing but 4. N is nothing but 2 capacitors are there. 4 by 2. That is equal to 2 microfarad. It means what? It means instead of these two capacitors, I am taking only one capacitor which is equivalent to 2 microfarad. So here I am taking that this is 2 microfarad. Observe carefully once again. This 2 microfarad and this 2 microfarad both are in parallel combination. In case of parallel combination, we used to take it as Cp is equal to C1 plus C2. Now 2 plus 2, that is 4. So instead of two capacitors, here I am taking that only one capacitor which is equivalent to 4 microfarad. 4 microfarad. Okay, now once again I'm taking 2 microfarad, 2 microfarad. These two are in again series combination. Instead of this 2 microfarad, here I am considering that Cs is equal to C by N. That is C is nothing but 2 microfarad. Like that, how many capacitors? 2. That is equal to what's the value? 1 microfarad. So instead of these two capacitors, I'm taking only one capacitor. These two capacitors replace with one capacitor, and that is nothing but 1 microfarad. 1 microfarad. Okay, and this is nothing but 4 microfarad. Okay, so 4 microfarad and 1 microfarad. Here I am taking that. Listen, ma. Four microfarad and 1 microfarad. The effective capacitance is C effective is equal to, both are in parallel combination, then 4 plus 1, that is equal to what's the value? 5 microfarad is the answer. This is one problem. Okay, and then take next problem. Take the next problem. See, in this question, identical capacitors C by N in series combination, energy is U1. Apply this formula. So the same identical capacitors are in parallel combination, energy is U2. Apply the formula, U is equal to half CV square. Cp is nothing but NC. Ratio here they asked U1 by U2. U1 by U2 is nothing but half, and here half cancelled. V square cancelled. In this C by N left, in this NC left. Then Cc get cancelled. Then that is U1 by U2 is equal to 1 is to N square. Okay. Now another model. The charge on capacitor of capacitance 15 microfarad. 15 microfarad in the figure given below. So here again one circuit diagram is given. According to that circuit diagram, listen, this is one capacitor, another capacitor, and third capacitor. The three capacitors are connected to the voltage source. That they mention it as like this, 13 volt. So now here they mention the capacities of the capacitors: 10 microfarad, 15 microfarad, 20 microfarad. These are the three mentioned. We need to calculate the charge on the 15 microfarad. 15 microfarad. What is the charge? For that, at first, we need to calculate the effective capacity. Three capacitors are in series combination. So we need to take it as C1, C2, C3 by C1, C2 plus C2, C3 plus C3, C1. C1, C2 plus C2, C3 plus C3, C1. Then C1, C2, C3, 10 into 15 into C3 is nothing but 20 by C1, C2, 10 into 15, 150 plus C2, C3, 15 into 20, 30, nothing but 300 plus C3, C1, 20 into 10, 200. Now, so 15 twos are 30, again 2 zeros are there, 150 plus 300, 450 plus 200, 650. 0, 0 get cancelled, and then that is 300 by 65. That is equal to 5 6 are 0, 5 1s are 5 3s are 60 by 13 microfarad. This is the effective capacity. We need to calculate the charge on 15 microfarad. Observe carefully. In series combination, the charge on every capacitor remain same. In series combination, the charge on every capacitor remain same. So whatever the charge is present on 10 microfarad, the same charge is present on 15 microfarad, and the same charge is present on 20 microfarad. 20 microfarad. So here I am taking that effective, nothing but according to the principle of capacitor, Q is equal to CV. So that is C effective into V. Then Q is equal to C effective is nothing but 60 by 13, and potential in the problem given that 13 volt. 13 volt. So now 13. Then 13 get cancelled. Q is equal to 60 microcoulomb. This is the answer. The same charge is present on 10 microfarad as well as 20 microfarad also. Got it? Okay, just note down. Complete, ma? Next question. 105. Check the 105. Listen. The capacitance of an air core parallel plate capacitor of circular plates of diameter D, separated by X, parallel plate capacitor. So C1 is equal to parallel plate capacitor. Here I am mentioning that C is equal to, what's the formula, ma? Epsilon naught A by D. What's the formula of that? C is equal to epsilon naught A by D. So C1, I am taking that C1 is equal to epsilon naught A by D. Epsilon naught A by D. In the problem given that diameter is D, Diameter is d, nothing but C1 is equal to epsilon naught. A means area of the plate pi r square by d. R is the radius. D is the distance here. According to the formula, R is the radius and D is the distance between the two plates or separation between the two plates. But in the problem, mention that diameter is equal to D. Diameter D means radius is equal to what's the one? R is equal to D by 2, half the diameter. Half the diameter. So in the place of R, I mentioned D by 2. Now, separation in the problem, the separation between the two plates given that X. So according to the given notation, in the formula, the notation is D. Formula notation, what's the value, ma? Notation between the separation between the two plates. What's the value? D. D is equal to what? X. D is equal to X. So here I am replacing the formula as epsilon naught pi. In the place of R, I used to write D by 2. D by 2 whole square, nothing but D square by 4 by, according to the concept, D is equal to separation. Separation in the problem given that X. Problem లో separation ఏమి ఇచ్చారమ్మా ఇక్కడ x కదా ఇచ్చింది x. This is the C1. Half of the problem this is. Then the remaining part of the problem is the capacitance of an air core parallel plate capacitor of circular plates of diameter d separated by x is same. ఈ వాల్యూ ఇంకొక వాల్యూకు ఈక్వల్ అయిందంట. సేమ్ అంటే ఈక్వల్ అయిపోయిందంట. Same as the capacitance of spherical condenser. So for spherical condenser, what is the capacity? For spherical condenser, what is the capacity, ma? C is equal to 4 pi epsilon naught R. This is the formula of capacity of spherical condenser or spherical capacitor. Okay, so C is equal to 4 pi epsilon naught R. Here radius is mentioned that D. ఈ కాన్సెప్ట్ లో in this concept, this is case 2 and this is case 1. In this concept, the radius is given that the radius of the spherical capacitor is spherical capacitor is equal to x. Sorry, in the problem given that D. ఈ ప్రాబ్లం లో ఏమి ఇచ్చారు అంటే D గా ఇచ్చారు. కన్ఫ్యూజ్ చేశారమ్మా. ఈ ప్రాబ్లం లో నోటేషన్స్ అన్ని దానికి నోటేషన్స్ కన్ఫ్యూజ్ చేశారు. కన్ఫ్యూజ్ చేసిన కాన్సెప్ట్ ను గుర్తు పెట్టుకోండి, బాగా అనలైజ్ చేసుకోవాలి నీట్ గా. ఓకే, సో ఏ కాన్సెప్ట్ కా కాన్సెప్ట్ సపరేట్. కేస్ 1 పార్ట్ డిఫరెంట్, కేస్ 2 పార్ట్ ఈస్ డిఫరెంట్. సో this I am taking that C2 is equal to 4 pi epsilon naught, radius mentioned with R, but in the problem radius is given that D. So now in the place of R I am writing D. These two values are equal. According to the problem, C1 is equal to C2. Then what we need to find out? Here we need to find out the distance of separation between the plates of parallel plate capacitor. Case 1 lo parallel plate capacitor kada. This is the concept related to the parallel plate capacitor. In this case, what is the separation? X. We need to calculate the x value. So here question is very clear. The separation between the parallel plate capacitor is the separation of the plates between in the parallel plate capacitor is. That is the question. So C1, what is the C1? Here itself is present, epsilon naught pi d square by 4 by x. This is C1. C2, 4 pi epsilon naught d. Now pi epsilon naught get cancelled. Fine. Square 1 square 1d get cancelled. Okay, then d by 4x is equal to 4. We need to calculate x. Take the cross multiplication. X is equal to this, x goes to numerator and 4 comes to denominator. 4 4s are 16. So d by 16 is the answer. Take it once. And then see the 107. 107. Can I rub this one? The total current supplied to the circuit by the battery is, so here one circuit is mentioned, this circle, in the problem they mentioned like this, and here one battery supplied like this. This is 6 volt, 2 ohm, 1.5 ohm, 6 ohm, and 3 ohm. This is a circuit given in the problem. Question is the total current supplied to the circuit by the battery is. So from the circuit, from the battery, how much current is coming? That we need to calculate. I value we need to calculate. I we need to calculate. Okay. So from the positive terminal, we observed at this point the current is dividing into 3 ways. 3 ways. Listen carefully, ma. Listen. I am rearranging this circuit. See, first take the battery. I consider the battery like this, 6 volt. No complication, 6 volt. From the 6 volt, at first 2 ohm is connected. This 2 ohm is connected, as well as next, how much? This is the variation, it's moving. This is 6 ohm. 6 ohm is here. And this is 1.5 ohm, 1.516. And next, one more is 3 ohm. 3 ohm also splitted from here. 1, 2, 3. But this 2 ohm is in between 1.5 and 6. 1.5 and 6. Okay, so that's why here in between 1.5 and 6, like this. Observe carefully here 1.5 ohm, one end is connected to negative terminal. So just I consider 1.5 is here, 6 ohm is here. Now this 3 ohm is directly connected to, see here 1.5 and 3. This is one end of the 3 ohm. This is one end of the 1.5. This 3 ohm as well as 1.5 both are connected. And that's why here I connected like this, 3 ohm and this is 1.5 ohm. The another end is connected to negative terminal like this. This is the circuit of that. From here current I is coming. Current I is coming. This 2 ohm, at first I considered 1.5 and 6. 1.5 is connected to negative terminal. So 1.5 ohm is connected to negative terminal. This is negative. See here. This is negative. Negative terminal. Okay. Now here, otherwise you without confusion place the battery here itself. There is no problem like this. Two ohm is connected to positive terminal. So at first take the positive, negative, positive. That's it. Now so current is moving like this from positive terminal, straight away moving to 2 ohm, moving to 2 ohm. Okay, so this is the 6 volt. Now for calculating the current, at first we need to calculate the effective resistance. Effective resistance. So 2 and 6, these two are parallel. In resistors parallel combination, effective resistance is R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. Don't confuse for the capacitors as well as resistors. In case of parallel combination of capacitors, C1 plus C2. Whereas in case of parallel combination of resistors, R1 R2 by R1 plus R2. Got it? Now, here, replace. For this, I am taking the calculation. This 2 and 6 both are parallel. R1 R2 by R1 plus R2. So 12 by 8. So here 4 3s are 4 2s are. 3 by 2 is nothing but what's the value? 1.5. So replace these two resistors, 2 ohm and 6 ohm with 1.5 ohm. And again 1.5 ohm, another 1.5 ohm is in series. Again, what's the value? 3 ohm. And as usually connect the battery like this. Replace this 2 ohm and 6 ohm, with 1.5 ohm. The effective resistance between 2 ohm and 6 ohm is R1 R2 by R1 plus R2. That is 1.5 ohm we got here. Okay, that value here I mentioned. Anyway, in the circuit, one more 1.5 ohm is present. So 1.5 and this 1.5 both are in series combination. Again, replace these two with 3 ohm. These two with 3 ohm. This 3 ohm and this 3 ohm both are in parallel. So in case of effective resistance, R effective is equal to both are in parallel combination, no? R by N. Here R is nothing but 3 ohm. Identical. How many identical resistors are there? 1 and 2. 3 by 2 is nothing but 1.5 ohm is the effective resistance. Now I need to calculate the current. I is equal to V by R effective. What is the V value, ma? What's the V value here? V is nothing but 6. R is nothing but 1.5. Then I is equal to 1.51 sir, 1.54 sir, and that is equal to what's the value, ma? 4 ampere. That is the current drawn from the battery. And then take the question number 112. 112. Read the problem once. The resistivity of a metal is 1 into 10 power minus I'm not visible of those powers actually. Very clumsy those powers are. So in the problem, I'm giving the formula for this. Then you practice. Those numbers are not visible actually to me. Okay, 10 power minus 8. 1 into 10 power minus 8. Okay, good. If it contains 9 into 10 power, what is the value? So anyway, the resistivity rho is given in the problem. 1 into 10 power minus 8 ohm meter. Okay, and then it contains 10 power 9 into 10 power. What's the value, ma? 28. Okay, 1 into 10 9 into 10 power 28 electrons. So here concentration of the electrons given in the problem 9 into 10 power 28 electrons per meter cube. So electrons per meter cube. Now then the relaxation time of electrons inside the metal is nearly. We need to calculate the relaxation time. So for that, rho is equal to, we have one formula, m by n e square tau. Rho is nothing but resistivity, m by n e square tau. What is the m? Mass of the electron. Mass of the electron, even though it's not given in the problem, we need to consider that 9 into 10 power minus 31 kg. That is the mass of the electron. That is the mass of the electron. Okay, E, charge of the electron. E is equal to 1.6 into 10 power minus 19 coulomb. Okay, so anyway, from the problem, tau is equal to m by n e square rho. N e square rho. M value, you know that, n value, e value, and rho value. Substitute and get the relaxation time. Okay. And then take the question number 114. Take the question number 114. Read the numerical in yourself at first. Two resistors P and Q, two resistors P and Q of temperature, coefficient of resistivity is 4 into 10 power minus 4, minus 4 into 10 power minus 4. The another one is 5 into 10 power minus 4. So one is alpha P minus 4 into 10 power minus 4, alpha Q, coefficient of resistivity of the Q, 5 into 10 power minus 4, mentioned in the problem. Good. Now, respectively are connected in series so that the effective resistance remains same at all temperatures. If the resistance of P at 0 degrees Celsius is 10 ohm, then the resistance of Q at 100 degrees Celsius is okay. So at first, at 0 degrees Celsius, what is the resistance of Q? We need to calculate at first. For that at first, at 0 degrees Celsius, the resistance of Q. We need to calculate. Okay. So for that purpose, here I am taking that alpha 1 R1 is equal to alpha 2 R2. In the problem, alpha 1 is nothing but P, 2 is nothing but Q. So here I am taking only number 4 into 10 power minus 4. R1 in the problem, at 0 degrees Celsius, the resistance of P is 10 ohm given in the problem. E value problem lo icharamma. Ee 10 ohm అనేటువంటిది problem lo icharu. Is equal to alpha 2 is nothing but 5 into 10 power minus 4 R2. So now R2 is nothing but this is at 0 degrees Celsius. Nothing but R2 itself is nothing but RQ, resistance of Q at 0 degrees Celsius is equal to, what's the value? 10 power minus 4, 10 power minus 4 get cancelled. 10 4s are 40, 5 1s are 5 8s are 8 ohm. At 0 degrees Celsius, the resistance of Q is 8 ohm. We need to calculate the resistance of Q at 100 degrees Celsius. For that, here I am taking the formula as RQ at 100 degrees Celsius is equal to RQ at 0 degrees Celsius into 1 plus alpha into delta T. This is the general formula which you know. R2 is equal to R1 into 1 plus alpha delta T. This is a general formula. But for your purpose, notations here I am specifying clearly. R1 is nothing but at 0 degrees Celsius resistance. R2 is nothing but at 100 degrees Celsius resistance. Here we need to calculate R2 value. R2 is equal to the same notation I am mentioning. R2 is equal to R1 into 1 plus alpha into delta T. This is the formula. R1 is resistance at 0, R2 is resistance at 100 degrees Celsius. So they said to calculate resistance at 100 degrees Celsius. So straight away I considered. With that, R1 is nothing but, what's the value? At 0 degrees Celsius, we found that 8 ohm. So 8. So this is RQ at 100 degrees Celsius is equal to 8 into 1 plus alpha is nothing but, what's the value of Q resistance? Temperature coefficient of resistance is 5 into 10 power minus 4. 5 into 10 power minus 4. And temperature difference is 10 square, 100 degrees Celsius. Delta T is nothing but 100 minus 0. 100 minus 0. Temperature difference. 10 square, that is 100 means. Minus 4 plus 2 nothing but minus 2. Then 8 into 1 plus 5 into 10 power minus 2. That is equal to 8 into 1 plus 0.05. That is equal to 8 plus 8 5s are 40. That is 0.4 you will get. That is equal to 8.4 ohm. This is the resistance at 100 degrees Celsius of the Q resistance. And then take 116. Next problem. Is this okay, ma? Good. Now, when a battery is connected to a uniform wire, read out yourself at first. When a battery is connected to a uniform wire, the current through the wire is 2 ampere. The current through the wire is 2 ampere. So this is initial current given in the problem. This is a case 1. I am mentioning this is a case 1. This is a case 1. Case 1. Now, here I1 is equal to, initial current I1 is equal to 2 ampere. 2 ampere. Here one condition is given, ma. The wire is stretched uniformly such that the stress is numerically equal to the Young's modulus. This is the combination of the question between mechanical properties of solids and current electricity. See the link up. It means only you are throwing with current electricity, no use. You need to remember the concepts of first year also. So every topic of physics is combined with some other topic. First year topic combined with second year topic, and they'll design the problem. Okay, so need to remember the formulae every time. Maintain one pocket book of respective formulae. Maintain nothing but you only prepare the formulae list, and every day, at least once every day, you need to spend at least 15 to 20 minutes on the formulae. Thereby, you never forget those formulae. Once Young's modulus, like these words are present, keywords are present, immediately recollect the formula of all the formula of mechanical properties of solids. Okay, then you will get one confident to do that problem. Otherwise, you not at all remember the content, and then how come you do the problem? Okay, so instead of doing the problem, instead of thinking about that problem, simply you can skip that, even though that is easy. So it's very, very important to remember the formula. Now observe carefully. Here one condition is given in the problem. The wire is structured uniformly such that the stress is numerically equal to the Young's modulus. Stress is numerically equal to the Young's modulus. Numerically equal to Young's modulus. Now stress is equal to Young's modulus is nothing but what? Stress by strain. Longitudinal stress by longitudinal strain. Longitudinal stress by longitudinal strain. Stress cancelled. strain is equal to 1. Cross multiplication, strain is equal to 1. If strain is equal to 1, here I am mentioning that delta L by L is equal to 1. That is a strain. What is the longitudinal strain, ma? Delta L by L. Delta L by L is equal to what's the value? 1. So with that, here we are taking that delta L is equal to cross multiplication L. L into 1, what's that? L. Now I'm taking that L1 is the initial length. L1 is the initial length. L2 is the final length. L2 is equal to L plus delta L. Initial length plus elongation. Initial length plus elongation. L means what? Initial length, no? L1 plus delta L is nothing but L. L is nothing but initial length again. That is L1. L1 plus L1. What's the value? 2L1. So L2 is equal to 2L1. Okay. Got it? L1 is equal to initial length. L2 is equal to 2L1. Twice the initial length. Now, in this concept, again, some more part of the problem is there. Now, if the above battery is connected to the wire, then the current through will be, previously, if L1 length of the wire is connected, current is I1. If L2 length of the wire is connected to the battery, then what about the current? That is the question. Question is very simple. If L1 length of the wire is connected to the battery, then the current is I1. Now, L1 replaced with L2. Now the length of the wire is L2. In this case, what is the current? That current is I2. I2 is equal to question mark. That we need to calculate. For that purpose, here I am taking that volume is equal to constant. For volume of the wire is constant, no? So volume is equal to constant. Volume is nothing but area into length. So that is nothing but A1 L1 is equal to A2 L2. A1 L1 is equal to A2 L2. Okay, then with that, I am taking that A2 is equal to A1 L1 by L2. So A1 L1 by L2 is nothing but 2L1. L2 is equal to 2L1. Then L1 get cancelled. A2 is equal to A1 by 2. The area of cross section of the second wire is half the area of cross section of the first wire. Now I'm taking that as you know well R is equal to rho L by A. First resistance R1 rho L1 A1. Second wire R2 is equal to rho L2 by A2. Okay, anyway, potential difference is, listen ma carefully, this value rho L2 is nothing but what's that? 2L1 by A2 is nothing but what's? A1 by 2. By 2 goes to numerator like this. Then 4 rho L1 by A1. Rho L1 by A1 is equal to what's the value? R1. So R2 is equal to 4R1. This is one condition we got now. R2 is equal to 4R1. Okay, now anyway, same battery is connected. Same battery is nothing but potential difference is same. So potential difference is nothing but V. This is the potential difference. Now potential difference is equal to V is equal to IR. It means I1 R1 is equal to what's the value ma? I2 R2. I1 is nothing but what's the value? 2 ampere. R1 here I consider like this. R1 is nothing but like this, is equal to I2 R2 is nothing but what's the value? 4R1. 4R1. R1 get cancelled. 2 1s are 2 2s are. 1 is equal to I2 into 2. Then I2 is equal to 1 by 2. That is equal to 0.5 ampere. This is the answer for that. See, the analysis of this problem is, at first, given condition is stress is equal to Young's modulus. With that, I calculate the strain. Strain is nothing but delta L by L, that is equal to 1. Delta L equal to L. Once the elongation is mentioned, here, it is very clear that initial length is L1, final length is nothing but initial length plus elongation. Final length is nothing but what, ma? Final length is nothing but initial length plus elongation. Initial length is L1, elongation also L1. Why? Because L is L1, initial length. L1 plus L1, 2L1. Now, R is equal to rho L by A. Here R is equal to rho L by A. First case, rho L1 by A1. Next case, rho L2 by A2. L2 is nothing but given in, we calculate the 2L1. A2 is nothing but half the area of cross section. From this, we calculate that volume equal to constant. To the given y, volume is constant. That is a condition. Now, with that, I substitute the values. Then I got that resistance between two wires, R2 equal to 4R1. Once we got the R2 equal to 4R1, now I am taking that same battery. That is a keyword. Same battery. Same battery is nothing but potential difference is same. Now, here, potential difference is nothing but IR. This is the same. So I1 R1 equal to I2 R2. This is same. I1 R1 equal to I2 R2. I1 R1 is equal to, I1 is 2 ampere. R1 is as it is. I2 we need to calculate. R2 equal to 4 R1. Then after calculation that I2, when the length is L2, the current passing through the wire is 0.5 ampere. When the length is L1, the current is 2 ampere. This is the analysis of this problem. Got it, ma? A uniform wire of resistance R is bent in the form of a circle. 2 points P and Q are such that arc PQ subtends 60 degree at the center, and another set of points X and arc are such that arc XY subtends 120 degree at the center. The ratio of effective resistance across P and Q to the effective resistance across X and Y is. Here, this is the problem related to the two cases. The first case is nothing but one arc is one circle is bent into two different arcs. One arc is making an angle 60 degree at the center. Another arc is making an angle 120 degree at the center. See here, a uniform wire is bent of resistance R is bent in the form of a circle. 2 points P and Q are such that on the circle, 2 points are considered. 2 points. Those 2 points are subtending as 60 degree at the center. So, first one, what is the total angle at the center? At the center, the total angle is 360 degree. Now, if you consider the circle like this, at the center, total angle is 360 degree. Now we consider only 2 points. This is the P and this is the Q. Like this they considered. These two are making an angle 60 degree at the center. 60 degree at the center. So this part of the arc consisting of how much resistance? How much resistance? That we need to calculate. For that purpose, here total angle is 360 degree. Then 60 degree consisting of how much part? That is 60 degree by 360 degree. That is equal to 1/6. 1/6 part of the circle. Total resistance is R. In that, this arc PQ RPQ. RPQ is equal to 1 by 6R. RPQ is equal to, what's the value, ma? This small part of the circle consisting of how much resistance? 1 by 6R. Why? Because in the total circle, how much part of the circle is considered? 1 by 6th part. So the resistance also became that much part. So 1 by 6R. Are you getting, ma? అర్థమవుతుందా? సర్కిల్లో ఈ ఆర్క్ అనేటువంటిది ఎంత పార్ట్ ఉంది ఇక్కడ? 1/6 పార్ట్. సో టోటల్ రెసిస్టెన్స్ కూడా ఎంత పార్ట్ డివైడ్ అవుతుంది? 1/6 పార్ట్ డివైడ్ అవుతుంది. సో 1/6R. ఇప్పుడు ఈ పార్ట్ 1/6R అయితే రిమైనింగ్ పార్ట్ ఏమవుతుంది? రిమైనింగ్, ఫర్ ఎగ్జాంపుల్ ఇది R1 అంటాను, దిస్ ఇస్ R1. దెన్ వాట్ అబౌట్ ద రిమైనింగ్ పార్ట్? Remaining part is R2, that is equal to 5/6R. How come that we got? In the total resistance, I am subtracting 1/6R. So that is nothing but 5/6R. How these two are? This part of the arc is in parallel to the remaining part of the arc. Remaining part of the circle. Remaining part of the circle. So now R dash is equal to R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. Now R1 is nothing but R/6. R2 is nothing but 5R/6 by R1 plus R2. If these two can be added, R1 and R2 then can be added, then you will get R. That is equal to 5R square by 36R. R get cancelled. 5R by 36. This is the R dash. Nothing but at the center, if you consider the 60 degree, the effective resistance is R dash. That is 5R by 36. Now, in this case 2 we have. Case 2. What is the case 2? Now the angle is 120 degree. Instead of 60 degree, what we considered? 120 degree. So 120 degree means how much? 120 degree by 360 degree. That is equal to 1/3. Now R1 is equal to 1/3R. Then R2 is equal to R minus R/3. That is 2R/3. 2R/3. This is R double dash I am taking. Again, effective in between R1 and R2. If you consider the 60 degree, effective resistance is R1 R2 by R1 plus R2, 5R by 36. If you consider like this, then here also same, R1 R2 by R1 plus R2, R/3, 2R/3 by R1 plus R2 means that is R. Anyway, R get cancelled, that is 2R by 9, that is R double dash. The question is the ratio of effective resistances, R dash by R double dash. In these two cases, in the first case, R dash is the effective resistance. In the second case, R double dash is the effective resistance. We need to calculate R dash by R double dash. Then with that, here R dash is nothing but what's the value? 5R by 36. R double dash is nothing but what's the value? 2R by 9. R get cancelled. 9 ones are 9 fours are. That is 5/4 by 2. That is nothing but 5/8. 5/8. That is the answer. 5/8 or 5:8. Got it, ma? Okay. So you try remaining models.